what we know and what we learned, that the unexpected downtime is a big issue in production. And often this unexpected downtime happened due to the break of mechanical parts. And there again, the AI, which is integrated in our robot servo system, can help to make a predictive maintenance of the parts, of the mechanical parts. So the algorithm, the AI algorithm, are looking to the real operation of the parts, of the motors, of the how the bearings are handled, and all the mechanical parts. So this is something which is not only comparing, I would say, fixed data, like comparing working hours. So like every 20,000 hours you need to make a maintenance. No, so with the AI, with the predictive maintenance function, it's really analyzing the load of the axis and so on. So finally, then the robot, the servo system, are making decisions based on real time and also on past trends. What I explained, the main mechanical parts in a robot are the bearings, the gears, and the belts. And these are always controlled because the system knows what the robot is doing for sure. It knows what has been done in the past. It knows the structure of these mechanical parts. And it can warn of a failure, of a wearing, of a breakdown in a really early stage already. So that means the downtime can be reduced. And the important point is the maintenance can be scheduled in advance. So it's a planned maintenance and not the sudden maintenance, what we said, what we learned. It will be the big issue in the production. But additionally, we are also already in an early stage, which means the design phase of the machine able to simulate such kind of maintenance capabilities. We can use our software tools, run the real, application in a simulation. And already there, we get the information when the parts need to have maintenance. So the maintenance, like the annual maintenance, can already be planned before the machine is working. And for sure, then you can already cover the cost. Or probably you optimize your movements and then get down the maintenance intervals. About the servo motion, we have learned that the auto-tuning helps also for the reduction, for the maintenance intervals. But also our servo motion system, have an AI-based predictive maintenance integrated. So if you have any external components, mechanical components are like ball screws, a belt or gear connected to our servo motors, the system can detect any wearing of the belt or increase the backlash of a gear, or even if the ball screw needs additional grease because it's getting more dry, friction will increase. So it helps you also to schedule maintenance, to give a warning before the products will fail, because this is a big topic. And so what we can say especially with our latest generation of servo system, we can make the predictive maintenance somehow in any kind of machine. And this is without any additional cost, because these predictive maintenance functions are integrated in the amplifier as a standard functions. And for sure, it will improve the machine, it will improve the efficiency of the machine, and it will improve the unexpected downtimes with, told like a big issue in the production.
And I think what is very important to stress is that the belts and the gears and so on, those are not integral parts of the servo. Those are external parts that are, crucial for the machine performance. But the point is that they are out of the servo system, right? Again, the servo is advanced enough to be able to recognize these problems even with the outside world, let's say.
Yeah.
So it's very advanced.
So any of these, I would say, typical mechanical parts like ball screw gears and belts, which are often connected to our motors, can be monitored, can be checked, and can be analyzed. So this is not for a typical part. And I think that's the big advantage and can be used for any kind of machines.